Recall that a piecewise defined function typically has different formulas for different parts of its domain, and therefore the graph consists of separate pieces. So we have here an example. We have h of x follows the graph of x squared between -3 and 3. We see the domain of this function extends from -3 to 7, actually to infinity because it's defined for x bigger than 7. And from -3 to 3 we have the graph of this function is the graph of y equals x squared. Now that does not include the x value 3, so the graph becomes the graph of y equals x between 3 and 5, including 3 but not including 5. So we use a solid point at the end of a piece of the graph of this function to emphasize that that point is included in the graph. So we see when x is 3 here, y is also 3, and so the point 3, 3 is on the graph. Now the point when x is 5, y is actually equal to 0, so the point y 5, 0 is on the graph, and so we use a solid point to denote that, and the graph becomes the line y equals x again between 5 and 7. Now it's equal to the graph of y equals x everywhere on this interval between 3 and 7 except when x is 5. And to denote that a single point is left out of the graph, at a point we use a circle to denote that this point is excluded. So this point, this circle here, indicates that the point 5, 5 is not included in this line. We might also put a circle here, which is blank on the inside, to denote that the point 3, 9 is not on the graph. And also, because the point 7, 7 is on the graph, we use a solid dot here, and then the graph turns into the graph of 1 over x minus 10, so the point 7 1 over minus 3 or minus 1 over 3 here is not on the graph, and we might put a circle there to indicate that. But every point on this curve y equals 1 over x minus 10 to the right of that is on the graph. Now notice here that the formula y equals 1 over x minus 10 does not make sense when x is 10, and so therefore there is no point on the graph with x equals 10. Now unfortunately on most graphing systems they include a line here which is not really part of the graph, but it does have a function. It's a vertical asymptote to the graph. So this is kind of like the this is very like the graph of y equals 1 over x, except it's the graph of y equals 1 over x minus 10. So it's centered at x equals 10, and basically it's the graph of y equals 1 over x shifted to the right by 10 units, and we'll see why that is in the next lecture. This vertical line is not on our graph, but it does have a role to play. It's a vertical asymptote. So this graph gets closer and closer to this vertical line as x approaches 10. We'll also talk about that in calculus and find the vertical asymptotes of various rational functions. So as x approaches 10 from the right, the y values approach plus infinity, and as x approaches 10 from the left, the y values approach negative infinity. We'll also talk about this when we study limits in calculus. For the moment, let's try to graph some piecewise defined functions, keeping in mind how we indicate when a point is left out and when it's not. Here we have a piecewise defined function. The domain of this function includes everything from -infinity to infinity. And we have 4 different formulas for what is happening. So the graph is going to be the graph of y equals x when -infinity is less than x, which is less than or equal to 1. Y equals 2x when x is between 1 and 2, but not including 1 and 2. And y equals 1 exactly when x is 2. So this is really just a point 2, 1 is on the graph. And then it's the graph of y equals x squared for x bigger than 2. So the 4 sections to this graph. And these two are just lines, so it's enough to have 2 points on these lines to draw them. And so let's use our join the dots method here to find a few points. Well, it's the graph of y equals x for all x less than or equal to 1. So let's look at the points x equals 0, x equals 1 to get 2 points on this line. And so when x equals 0, y equals x, because 0 is in this interval, and that's 0. And when x equals 1, y is also equal to x, which is equal to 1. So the point 0, 0 is on the graph, and the point 1, 1 is on the graph. For the next interval, between 1 and 2, the graph is the graph of y equals 2x. Now, I'm going to take the n points. This is the graph of a line, and it has every point on the line except the points when x is 1 and x is 2. But I'm going to use the points x equals 1 and x equals 2 to get me 2 points on the line, the big picture of this line, so that I can join them and draw the picture of the line between 1 and 2. So when x equals 1, 2x, and notice I'm not saying this point is on the graph, I'm just saying 2x equals 2, and the end point of this line segment is 1, 2. So the end point of the line segment which is on the graph is 1, 2, but that point is not on the graph. So the point 1, 2 is not on the graph, but every point on this line to the right of it where the x is less than 2 is on the graph. When x is 2, 2x is 4, so the point 2, 4 is the other end point of the line, but 2, 4 is not on the graph. But every point on the straight line joining these 2 points for x between 1 and 2 is on the graph. Now for x actually equal to 2, the y value is 1, so the point 2, 1 is on the graph. All of these points are on the graph. And for x bigger than 2, the graph looks like y equals x squared. So one endpoint, which is not on the graph, if x is 2, x squared is 4, the point 2, 4 is an endpoint, but it's not on the graph. And if x is 3, y equals x squared, which equals 9, so the point 3, 9 is on the graph. So I have a bunch of points which are on the graph and a bunch of points which are not. but they should help me draw the graph of this function. Well, let's see what's happening. We have our y values are basically concentrated around 0. So I'll let the x values basically concentrated around 0. So I'll let the x run from -3 to 3. And the y values run up to 9, so I'll let my y extend between -10 and 10. So here are the x's, here are the y's. Now for this first section, I have 2 points on the line y equals x, the point 0, 0, and the point 1, 1. And these 2 points are on the graph. So there's 0, 0, here's 1, 1, and basically that line y equals x that joins those 2 points to the left of 1 is part of the graph, including this point at the end, 1, 1. The next part of the graph is the graph of y equals 2x, but it doesn't include these endpoints 1, 2, and 2, 4, but nevertheless they can guide us as to what the graph looks like. So the point 1, 2, and 2, 4 are here. We'll use the empty circles to denote that they're not on the graph, but everything on the line joining those 2 points in between is on the graph. That's the next part of our graph drawn. Now when x equals 2, y equals 1. So the point 2, 1 is on the graph, and we'll denote that by a single dot. And then the graph turns into the graph of y equals x squared, which is the parabola we saw earlier, to the right of 2. So its endpoint here, when x is 2, is not on the graph, and that's a point 2, 4, which we already have drawn here. So it starts out here, but that point's not on the graph. And then it moves to the point 3, 9, and then it keeps going up in this parabolic bowl-shaped graph. So we see here this solid dot, this point is on the graph, this one's on the graph, this one's not, and this one's not. And that gives us a picture of our piecewise-defined function. Here's another piecewise-defined function which you should be familiar with by now. It's the absolute value function. And what does its graph look like? Well, we can just pick a few points. This is the graph of y equals minus x for x less than 0, and y equals x for x bigger than 0. And you can pick a few points, see what's going on. Here we have y equals minus x, which equals 2. So the point minus 2, 2 is on the graph. Here we have y equals minus x, which equals 1. Point minus 2, 1 is on the graph. Y equals x, which equals 0. Here we have y equals x, which equals 1. Y equals x, which equals 2. So we have the points 0, 0, 1, 1, and 2, 2 on the graph. If you draw these, you'll see this graph is a V-shaped graph. All of the y values are positive, and it looks a bit like this. It's symmetric around the y-axis. It's the straight line y equals negative x, just a diagonal part of the diagonal of the plane there to the left, and the line y equals x to the right of the y-axis.